The Tiltbot was an interactive robot that Hannah Karras and I worked on for a workshop at the Bangor Discovery Museum. We began by making a proposal that we showed in class, and our idea was to make this robot that reacted whenever you touched it or moved it. It would light up and make noise. We used a tilt sensor, 2 LEDs, a touch sensor, and a speaker. Originally, we proposed using a Velcro board with different pieces that kids could move around to arrange code. We figured this would be a really good idea because it gave them a tactile experience with the code, which would help with their memory and help them feel more involved. Then we moved on to making a more formal proposal. We looked at the educational value, interactivity components, and the timeline and roles for this project. We then moved on to prototyping the electronics for this project. We worked with the Arduino Uno and added all the different sensors we would need. We arranged the code in tabs and processing so the kids would only have to look at the part of the code that was pertinent to what they were working on. This allowed us to prototype one component at a time, so each kid could complete one step of the project. Next, we designed each part of the code as a puzzle piece in Illustrator. These are what kids used to arrange the code on the table out in front of us at the workshop. But when they thought they had an answer, we'd upload it to the Arduino and let them test their code. Finally, we designed the robot housing in Illustrator and cut it on the modulars. The front side of this housing came off, so we'd be able to add components to it during the workshop. We also made and printed a cheat sheet for us to use during the workshop. Just in case our mind went blank when a kid asked us a question, we'd have a quick reference where we could look at the code and the wiring diagrams to this project. We thought the workshop was pretty successful. Kids got pretty excited when we told them that they get to make part of a robot and get to come back later on to see what we'd made. Eventually, once the robot had been made, we decided to keep one component out and show kids to make a type of component that was inside the robot, so they could make something like this at home. A lot of people at the workshop were really excited about the idea that they could continue to work on things like this at home. We ended up telling a lot of them about Arduinos and where they could get them. We were also excited to provide another step towards coding for a lot of these kids. Many of them had used Scratch before, but hadn't actually used a programming language like processing or Java. I feel like this was a good introduction for them that made it not so intimidating, because the puzzle pieces were analogous to the pieces in Scratch. If we did a workshop like this again, I'd like to make 2 versions of the robot, one finished and one open where the components are accessible. This would make it possible for kids to see what the final product was going to be, so they could see how their component contributed to the whole, and also make it easier for kids to work on a component without having to take apart the robot over and over again. It also would have been good if we had 2 Arduinos set up with 2 cords, so we didn't have to keep unplugging and replugging and reloading different programs on each one. Despite these drawbacks, we feel like this project was a success, as it was still informative and engaging for the kids at the Bangor Science Museum.
Discovery Museum.
Right.